I am Dian. Um, and yeah, I currently work at Apple. I used to be a graduate at Stanford. Previously, I was studying computer science and electrical engineering, but currently I'm a machine learning engineer at Apple. So my work mostly focuses on machine learning models in terms of modeling from the entire pipeline, from infrastructure to deploying models, and even yeah, basically like gathering models as well as deploying them. I will go into depth later in the lecture, but first of all, I want to get everyone started with a fun question. So I want to present a case study. So assume that, let's say, you all watch Netflix. Like we watch like TV shows or like any kind of movies. Like I'm using Netflix as an example. People could be watching YouTube. So when you first log into Netflix, this is what you see in the main page. Um, you see things like what's trending now, or like let's say a category that's relevant to you, and also like top shows in the US or Malaysia today. You see this everywhere. It's not just on Netflix. It's also on YouTube. It's on Spotify. Like where do these rankings come up? Like I never really thought about that. I just assumed that, oh, like maybe they just know how to read my mind. But actually, how do you think that they know what your preference is? That's where I want to like come into the idea of how does Netflix, or I'm using Netflix interchangeably with YouTube, how do they decide what you should watch next? So a very common thing is basically like you can scroll both horizontally and vertically. Vertically gives you different genres, and it also gives you kind of different categories. Whereas horizontally, it shows you the category within the dramas. So overall, these are like high focus at at the very first row or the very first column. And overall, like as you keep scrolling, essentially it's less likely that you'll watch them. So for example, I'm using K-dramas as an example because I recently just finished one. So assuming that I just finished Crash Landing on You, it is really likely that I'll watch a K-drama next. So like let's say it's almost just probabilities. But on the other hand, it is very unlikely that, let's say, if I just finish a comedy, I will watch a horror show next. So you can assume that horror genres are probably ranked lower in the list. So overall, like this is what statistics is about. It's like how it's applied to data science and machine learning. I'm going to go into the subfields of like what machine learning, data science, or like software engineering is in this field. But I want to use the example of recommendation systems as a case study. This is actually widely pursued in different companies. So for example, Amazon, Netflix, Google, YouTube, like there is a whole dedicated team in Google that I'm aware of that basically works with Google Ads, that they basically try to optimize ads for you. I'm personally not a huge fan of ads, but I actually think about all these things in terms of like, let's say Amazon, how do they rank products? Or let's say you would use like Taobao or like all these different products. Essentially, like let's say you would start. Have you ever noticed that when you start searching things on like Amazon, or let's say you start searching for things on like Shopee or something, and overall you will find similar recommendations based on what you search. This is actually relevant in most of the interactions with the internet, be it like websites, products that you're shopping for, blogs, or news. And here we have the example of like how do we carve a good recommendation system for the user. To formally define it, let's say we can define like a set X as a set of users and set Y as a set of items. We overall want to find, let's say, an utility function, U, which I call here, that basically takes in the input of X and Y and gives you a rating R. So for example, the rating for Netflix could be like, let's say 1 to 5 stars, for IMDb. It could also be like a scalar between 0 and 1, however you want to define it. But it basically like maps from users and items to a rating. So without knowing, like, let's say if I ask you all to build a recommendation system to me, like if there was no recommendation system at all, how would you do it? A really interesting idea to start with is something called content-based recommendations. So for example, you would recommend items to user X, similar to items previously rated highly by X. So let me rephrase it a little bit. For example, given that you don't care about the user at all, you focus solely on the content or like the items. So for movie recommendations, you would recommend movies with the same directors, actors, or genres. So for example, if I really like a Christopher Nolan movie or action movie, I would watch another Christopher Nolan movie as well. I don't really care about like what other people watch. It's mostly just about like the same directors, similar features. And there's also other things as well, like websites, blogs. There is a whole program at Twitter or let's say at Facebook where they have to like actually figure out how do you balance both the left wing and the right wing. So let's say if you keep engaging in like more liberal thoughts, you actually see a lot of liberal like content on your feed. This itself is a problem that like a lot of companies like Facebook, Twitter, they're actively trying to solve. And it's a very relevant team moving on forward. However, it seems like a very good approach, but there are a lot of limitations to this. So for example, how do you find appropriate features? How do you basically like, given like a video, how do you basically find a good representation for it? And that's where like I will talk about this in the future, but that's where machine learning comes in. But there's also things like how do you recommend for new users? Like because you're completely ignoring it from the user perspective, everyone else is seeing the same feature. Like people are very diverse, people have very different interests, and it never recommends things outside of the user's preferences that are specifically tailored to them. So it is very over specialized in a sense that it focuses a lot on the content itself rather than the person themselves. So that was the first idea of building a recommendation system using content-based recommendations. And here's a different example. Again, going back to the example of K-dramas. Let's say user one is a career blue, which is like crash landing, watch a startup. And user two is like, well, user two does not know user one at all, but it searches for dramas with the cast of crash landing. And the recommendation engine recommends, so yeah, it recommends startup because it's similar to what others have searched before. And this takes into account of the users rather than just the content itself. So it's called user-user collaborative filtering. So the main idea is, let's say you consider a user XT, because I'm using T as a target. So you will find other users, X1, X2, or like a different set, whose ratings are kind of similar to XT. And you can estimate the target's ratings based on everyone else's. So rather than just focusing on purely the content, you're also taking into account of others' preferences, and it's more diverse in that sense. And why did I use recommendation system as an example? It is a very challenging question, and people like Netflix have been trying to solve it. There is something called the Netflix Prize, which started in 2006. It essentially is a competition for people to find out what the best collaborating filtering algorithm is. And the winning team was awarded like $1 million to basically try to make sure that like we could solve this problem. And a lot of these problems are still remain, they still remain unsolved. There is a lot of work to be done because like companies are actively recruiting to try to improve their recommendation systems. So to dive a little bit deeper into the details and how it's relevant to data science, in a classic machine learning framework, you usually have an example of like a training data, and you also have validation set and test set. So for the training set, that's where you would train your algorithms on. You would evaluate it on the validation set, and then from that, you would then like publish the results on the test set. That is to avoid memorizing the training data. And with 1 million ratings, like how do you basically fit 1 million data points into a single machine? So for example, let's say if a single data point takes about like a few megabytes, how do you scale to such large data regimes? That's when interesting approach starts to come in terms of scalability. So for example, there are key needs for algorithms like MapReduce, dimensionality reduction through like SVD, or also PageRank. These are more specific terms that's used in industry in terms of how do you basically scale up. I've worked with MapReduce before in terms of basically how do you improve computation speed, how do you basically like work with large data regimes. So this is like a focus in terms of like industry, like scalability is a very important issue. So I've previously talked about data science, but I also want to give the overarching picture about how it relates to other fields. So previously, when I was like an undergraduate student, I used to think that all of them are the same: artificial intelligence, machine learning, deep learning, data science, and data analytics. Overall, there is some similarities in between them, but there are still largely a little bit different. So I'll go through them like one by one. Artificial intelligence, back then, this was invented like in the about like 20 to 50 years ago. So what they do is basically they focus on like the different algorithms, like, things like, let's say support vector machines, or like the more decision trees. And machine learning came in as well. Basically, it's data-driven approaches to solve the decision-making problem. Deep learning came in the era of like when it especially picked up popularity when GPUs were mostly used for deep learning. That's basically when convolutional neural networks like CNNs were developed by Yann LeCun, and then that's when deep learning tries to basically like add more deep learning layers to solve the machine learning problem. Big data itself concerns how do you deal with distributed data sets, like how do you basically gather 1 million data samples of Netflix recommendations. And data science itself concerns with a lot of things. So for example, I know friends who work at Robinhood or work at other places where they use data science to kind of like visualize, to do data visualization, to monitor metrics in industry and make sure that their performance don't degrade over time. So these are like a rough ideas about like what the fields are in like industry. So since my job is a machine learning engineer, or like I also work mostly in deep learning, I would use deep learning or machine learning as an example and basically say why I actually chose this field. I really love like thinking about like machine learning and deep learning as an analogy with mathematical functions. So in classic mathematics, you actually see that like a function basically maps an input to an output. So given some input x, you can map it on output y. And basically we are trying to fit a function to this. So for example, let's say you're trying to learn, you have a function x squared. Let's say you have an input of 1, it maps to 1. Input of 2, it maps to 4, so on and so forth. Now, let's say what if instead of just scalar values, you can basically generalize this input domain and output domain. So I will give examples about what this input domain and output domains are in the future. But what machine learning does is that this function is learned. You are not basically designing a function from scratch, but using data, you do gradient descent to basically optimize for the function parameters through machine learning or gradient descent specifically. So what it means is, let's say if you're given me a pair of x and y points, I don't know what the function is, but basically I can learn the function's data through machine learning by using gradient descent. And this generalizes to a lot of things. So for example, I would use the example of, let's say, a feature vector. So given like a vector of zip code, square feet, number of bedrooms, so on and so forth, and the distance to city, I try to predict the housing prices of a given place. So for example, like I would have like a data set of, let's say, the Boston housing prices back in like 2019. And then basically I can fit like a function data to this to try to predict housing prices of like similar distributions. So it seems like we don't just map from feature vectors to scalars. There are also a lot of interesting things that deep learning can do. So for example, there is a paper called Pix to Pix. It's one of my favorite papers. Essentially what it does image to image translation with adversarial networks. So essentially what image to image translation means that the input domain is an image and the output domain is also an image. So it maps in an input from, let's say, satellite imagery from the bottom left. It directly maps it, it maps the satellite image directly to the Google Maps output image. And you can do conversion from daytime to nighttime. You can do a conversion from lines and edges to a realistic photo, or even black and white to color. Like the limitations of, I think there's a lot of potential to this field in how do you do this image translation. So rather than just mapping from feature to scalar, you can basically generalize it from image to image. Because after all, you can think of image as like huge matrix of just like RGB values from 0 to 256. Essentially, it's like a huge vector or matrix specifically, and you can map from like a matrix to a matrix. And there is also a lot of huge application in terms of industry. So let's say this is one of my, this is also like one of the classic examples that's used in perception. So basically YOLO V3, it is used in detection. So for example, we have a demo here that basically maps, oops, 1 second. Yeah, it basically like given an image or like a video, it essentially maps from, it tries to detect where the location of the object of interest is, and it also assigns the label to it. So for example, like let's say you could assign things like person. Given this image, you'll learn to locate where the person is and also give like a probability vector of like what the label of this object is. So I think it's used in, yeah, it's used in like image segmentation, like, you know, it's used in like all these algorithms that's used in perception as well. This is just like a demo video of like how YOLO V3 works. I like personally, when I was first learning about deep learning, I find this pretty cool because let's say if you try to ask me to annotate every single person, I would find it really challenging. And we also have a lot of different things. So people do like action recognition in sports. So for example, given a video, what it does is basically it tries to label where the person is and what the athlete is currently doing. So you can basically see that like they're actually like, using this to kind of classify what actions are being performed by who, and you can learn to generalize this in a large scale. There's also other cool categories that's also used. This is also one of my favorite categories. Essentially, it's called neural style transfer. What it does is basically you are given two images. One is an input image on the left. One is the style image on the right. You are basically trying to incorporate the style of the second image to the first one. So let me show you. So for example, given this input image of a town, and this is like a piece of art. Yeah, this is like a piece of art from like an artist in the past. What you're trying to do is basically incorporate this style to directly translate this to a similar art form. Let me try to play it again. Yeah, so this is the original video, and you can see that you actually like could convert it in real time to, let's say, a similar art form. So for example, this is like a movie, and you could also like translate it from this domain to the other domain, or you can also categorize it based on the different art forms that they have. So I think deep learning is actually trying to solve this problem of generalization and representation. So let me repeat that. If I feel like the core of deep learning is essentially trying to address two problems. One is generalization. How do you deal with data you have never seen before? And the other one's representation. How do you represent data in a good form? So besides images, like previously I've only shown examples in images, we can actually see that deep learning is also applied in other fields. So for example, there's natural language processing. Traditionally, how do you translate languages? Is basically, let's say you're trying to translate from English to French. This seems like a rather easy example, like it's like a one-to-one translation, But in other tricky examples where there is no direct translation from English to a different language, this is where things get tricky. So in French, there is a word called entati. So entati essentially means hit someone with a pie, but there is no direct translation from entati in English. So therefore, how do you basically handle all these different fields? This is where like machine learning comes into play. So right now, if you go to Google Translate, if you type in a word, I assure you that they're basically like querying a machine learning model in the background and basically returning the results back to you. Besides machine learning in computer vision and natural language processing, there is also another one called reinforcement learning. What reinforcement learning does is essentially like it basically tries to learn good actions through it tries to learn good actions for an agent by basically like try and repeat. So you're basically giving it some reward. Let's say giving like a positive or negative reward, and the agent will try to learn or perform an action for it. So DeepMind is basically one of the research labs that basically deals with reinforcement learning. And this was a video of them basically training an agent to play Pong. So let me skip to this. So what the algorithm takes in is just like 4 consecutive images of like this image. So let's say they'll take in the consecutive images of like, let's say where the ball is and what the state of the world is. And essentially like this is initially during training. Like at the start of training, the agent performs pretty bad. But after 2 hours of training, this is when like the model actually plays really well. Like it actually like it would try to learn different tricks and hacks to basically achieve a good score. And the thing is like in this research, DeepMind didn't give an example of like how do you train this model. They don't give like human demonstrations. What they're giving is just like a reward signal saying that like if it's basically just giving a reward signal. And it also learns to exploit. So here the machine actually learns to basically like tunnel all the way like to the back. Yeah, it will tunnel to the end of the back and then basically using that as an exploit to, this is when like things happen naturally this is how it basically learns to optimize it. There's also other thing, like for example, reinforcement learning is also applied by OpenAI. So actually a background, I actually used to play Dota 2 a lot when I was a teenager. I think I clocked in more than 1,000 hours of Dota 2. I played throughout like middle school, primary school, and I love this game. But OpenAI actually like trained like OpenAI 5, like reinforcement learning agents, and they basically beat OG in 2019. So what they did is basically they used reinforcement learning they train for like 1,000 petaflop days. It takes like forever for them to train through self-play. And from that, basically learn to be the world champion in OpenAI. And these were like really good players too. Like they're like state of the art. They know all the strategies. They have like insane team synergy. But reinforcement learning agents actually help beat them. So yeah, overall, that's like the rough field of um, ML that I will briefly cover today. And I'll just cover things like how does ML work in industry. So roughly what it works today is basically this like the AI infrastructure, like, this is like the development cycle of an AI project. So you are given some fundamental infrastructure. So basically this would involve like compute machines. This would involve like all the necessary things required to set up the machine learning pipeline. And usually how I start first is basically as some data engineering. So given like a data set, like a Netflix data set, I would think about how do I engineer a solid choice of the data. So for example, like how do you figure out what the input vector is? So in the case of the housing prices, you can basically like collect data points of like, let's say, zip codes. You can collect data points of um, trying to think which features could be important to give the most information to the things that you want to predict. And next, you will do the modeling part. So modeling would involve things like training a neural network. You could also train like a subject vector machine or decision tree or similar fields like this. And basically try to optimize for some loss function. So let's say if you want to make sure that you want to minimize the loss function of mean squared error, then you basically like, you would perform gradient descent in that and make sure that you get like the smallest result, like the smallest loss as possible. And this is where good practices come in terms of like how do you handle like the training set, validation set, and test set separately, so you minimize information leakage. So after you've trained a model, what it does is basically like you take the model that you've trained, you deploy it in real time. So for example, let's say people want to use your model to predict housing prices in the future. You would basically like integrate it to a web app. So when people fill in information, you would basically output some data points that's predicted by the machine learning model. So after the deployment step, that's when business, like, people kind of do some analysis to it. People will say that, oh, let's say we're performing pretty well on like a certain city. Like let's say we perform pretty well on like Kuching, for example, but you're not performing as well in like the rural areas. And then that's when you go back to the table and try to perform like data engineering again. So let's say I would gather more data sets from rural areas, or let's say I would improve like, besides using zip codes, I can add in more information. Let's say like density of the city, and then the cycle repeats. Essentially, it's how you build up good machine learning models in the workplace. There are also several technical roles in industry. This is where like things get interesting. So given the different workflows that I've talked about, there's data engineering, modeling, deployment, and business analysis. Roughly on the x-axis, this is basically different stages in a machine learning project. And of course, AI infrastructure itself is like a fundamental. Like I think everyone else like would be building on top of AI infrastructure. A data scientist would mostly be involved in data engineering and modeling. So basically like, and also business analysis. Machine learning engineer, that's what I mostly focus on. I work in the first three halves of like the data pipeline. So for example, like how do you engineer how do you figure out what good data is? And then from this good data, how do you build a good model to it? I would say I focus more on the modeling side. I've also done data engineering and deployment in the past as well. And deployment basically means that now that you've trained like a machine learning model, how do you translate it into real life? And then that's where the connection comes in. A data analyst basically focuses on the first and the last one. So like data engineering and basically business analysis. So that would involve a lot of like data visualization, figuring out what the trends are. And sometimes they would be the one dictating where the project should head to next. Because once you do the analysis, that's when you try to reiterate and do like iterate on your errors. Software engineering ML. I think this is the one where I feel like a lot of my friends are in. So basically like at Google, they recruit a lot of like software engineering roles specifically for ML team. So you are not working exactly as a researcher, but what you're doing is basically you're a software engineer who has experience in machine learning, and you would do maybe some modeling involved, like a little bit. But most of the time you would be working on AI infrastructure, data engineering, and deployment. So I know that people who worked on like Google Cloud, Amazon Web Services, AWS, a lot of these people are like software engineering. Machine learning researcher machine learning researcher mostly involves in coming up with new algorithms. I would say almost like 90% is focused on modeling. And these are like the people who are like really good at math, I don't like, yeah, like I think they are really good at basically coming up with new algorithms, publishing at top conferences, and like innovating, you know, in terms of like doing grad school and basically like trying to really nail down the modeling work. And software engineer, like they could be involved in both like data engineering and AI infrastructure. I could also add in some deployment in there as well. But this is roughly like what the industry standards look like for technical roles related to data science and machine learning. And yeah, so now's the fun part. I can share a little bit about myself. I actually grew up in Kuching. So I went to ESL. It's like, that was like my first 6 years of education. And then I was at Zhonghua Middle School number 1. And then that's where Nico taught me for like a few months there. And I was there from like grade 7 to grade 9. Or in Malaysia, they call it Form 1 to Form 3. And yeah, so I grew up in Kuching. I was there for primary school and earlier half of like lower secondary. And I was offered an ASEAN scholarship to move to Singapore. So that's when I went to Singapore to study for high school and like National Junior College. So I did my O levels back in Bukit Panjang Government High. That's when I focused a lot on like science and mathematics, because that was primarily my interest. And then for A levels, I focused on physics, chemistry, maths, and research. I actually used to do chemistry research as well, but I thought that I was going to be a chem and physics major, but I actually like moved to electrical engineering. And yeah, so and then after that, I moved to California, like the Bay Area for college. I went to Stanford University, and then that's when I did my undergrad in electrical engineering and math. Um, and I also did my master's in computer science. So I focus on machine learning, information management, and analytics. So how do you do with big data? How do you do with like huge data sets? And machine learning in terms of like algorithms and modeling structures. So yeah, if you're interested in this, I also like recommend the following lectures. Like machine learning is really good. The first one is basically really good for like the mathematics fundamentals. Deep learning is basically a very good overview as well. I highly recommend the second one. I think there are like lectures video on YouTube. They also have slides involved if you want to self-study them. Like I did a lot of self-studying back in like when I had my free time because I was just interested in them. And if you're interested in computer vision, like the ones where I've shown in terms of like number pixel-to-pixel translation, how do you do like neural style transfer from like movies, incorporating a different image, that's when computer vision is. Natural language processing also talks about how do you do like language translation and how do you represent languages better. And reinforcement learning like DeepMind and OpenAI, there's also a class for that. And the mining massive data sets deals with like, they talk about like, the Netflix challenge and how do you do with like huge data regimes. And let's say if you're interested in pursuing this field in depth, there's always job opportunities to look out for. I think that even though right now, like the US market isn't the best, like I feel like we're going to bear market territory, but I feel like overall long term, there would still be a lot of like job opportunities for that. Like the labor market is pretty tight. And I feel like a lot of people are interested in basically machine learning hiring. So for example, I think Facebook froze hiring this year for software engineering, but they're still like actively recruiting for machine learning engineers. So they would be like indicator of like, you know, what people would like to pursue. And of course, like I definitely recommend like if you want to do a lot of this stuff, like you can seek out advanced studies. So for example, I think especially when it comes to like modeling or like a research scientist, I know that Google, like a lot of places, they actively try to hire PhDs. And if you do grad school, they actually do cover like tuition, like in a lot of US colleges. There's also like other paths as well. Like you could seek internships, fellowships, and residencies. I know people who did residencies where let's say they join for like companies like OpenAI for like 1-2 years, and then basically they would transition to like research scientists, like explore different career paths. And yeah, so let's say if you're interested, I can, you know, like where do I learn more? So I definitely recommend like brushing on the mathematics fundamentals. Things like linear algebra is very important for deep learning because like a lot of deep learning basically involves like matrix multiplications, dealing with matrices and tensors. Probability and distributions are also very important. I feel like the first two are basically like the core math fundamentals that I would recommend everyone to have if you would choose to go into this field. So distributions give you a good idea about like, why is my model failing? Because probably your test data is out of your training data distribution. Um, Programming is also really relevant. Like you should at least know things like dynamic programming, data structures, and algorithms. If you're actively trying to be like individual contributor, that's when I recommend lead code. If you're trying to like brush up on your programming skills, and optimization is less important, but I feel like it would give a very good intuition about like how things work and like how do you get like a good model. in terms of frameworks, like a lot of people use Python in industry these days. Unless you work on deployment, that's when I know people work on C++. But for fundamentals, like, I definitely recommend being really familiar with NumPy, SciPy, Matplotlib. If you want to work on data science, Pandas is a good tool because it basically deals with like large data frames, and also like visualization as well. For distributed computing, like basically how do you scale up? Spark, SQL, those are important. Spark is used for map and reduce jobs to basically like collect data really quickly. SQL is used for databases. And deep learning, this is the one where I'm most familiar with. I work with like PyTorch. Google uses TensorFlow or JAX, and so on and so forth. There's a lot of frameworks out there. And yeah, how do I get there? I would say that, like if you're interested, learn from online lectures, trying out assignments. And a very cool idea is basically like there's a lot of things on GitHub. So I would just search GitHub, deep learning, like pigs to pigs or something. People would probably have like an open implementation of that. And you can basically clone it, try it out to see if that works. There's a lot of good resources as well. Like Google Colab gives free GPUs. So you can basically try running your code on GPU like in the cloud. And of course, like, you keep building, iterating, and try to figure out like how do you improve on your algorithms. But yeah, I think that's a rough idea of like my presentation, and I can handle Q&A. So. Cool. Let me see.
All right. Thank you, Dian, for the generous sharings, the tips and tricks on how you land on where you are now, and also your personal journey. I think you basically summarized what I have taught in one semester in 1 hour. Thank you for that. And now we can move on, to the Q&A sessions. So I think we have started collecting questions already from the participants when you were sharing. And these are the list of questions that they asked anonymously via Slido. So I would just like you to, go through there and just answer whichever that you would like to answer.
Right, sure, yeah.
Maybe I start from the bottom because it's by the order of recency.
Yeah, sounds good. So how did I manage to study and land a job in the US? I think that was because I did, I think, my undergrad here. And then while I was doing my undergraduate, I actually did like, try to actively look for internships. And I know what people have done is basically they've done internships in like different places. And then they also like try to request a transfer to the US as well. So I feel like getting internships and experience is a good way to kind of like, put yourself out there, and also build up a resume really well. In terms of like work-life I think I'll go by category. So let's say things about like studying and working in the US first, and then I'll go into like, let's say, work in terms of um, yeah, my work at Apple, and then specifically as a machine learning engineer. Other questions? Yeah, I feel like a lot of those jobs are also like, really relevant in other places, Malaysia, Singapore as well. I know that there's a lot of other offices. So I think Google has offices in Singapore, Taiwan. It's not just about like solely in the US. And I know what people have done is basically they've done like internal transfers from one location to the other. Yeah, at least that's like my impression of it. And then I'll go into like, yeah, so about the job part first. How important is CGPA to land the first job? I feel like in my experience, a lot of recruiters look out for projects. So they look out for your experience rather than your GPA. So they don't care, let's say in the US, GPA is out of 4. Like they don't care like whether you get like as long as it's not too terrible, like there's a certain baseline, but they don't optimize specifically for grades. They care a lot about the projects you've done. And I think more importantly, like your past work experiences. So like, for example, like what people usually do is like they try to get internships and they try to build a resume of different internships as well. And yeah, and I'll go to the AI questions. What is artificial general intelligence? Okay, a lot of now researchers actually like really have hot debates about this question about whether AGI is fully, you can truly solve AGI. So there was initially OpenAI's mission. How do you basically make sure that like, let me backtrack a little bit. A lot of the work that we see in like machine learning today is specifically trying to solve for one task. So let's say I try to basically do image to image translation, or let's say people will say that I will try to convert from image to predict, let's say, a certain number. And these are task specific. And what AGI tries to do is basically they try to amalgamate, like they try to say, can we actually come up with machine learning model that kind of like stimulates consciousness, or let's say we can try to solve all tasks necessary. I feel like this is a hot debate that I don't want to get myself into, but overall, like there are a lot of innovations in the field that try to like get there. So things like multitask learning, meta learning, they try to just have models that solve different tasks together. And I feel like we are still like years like away from trying to solve AGI. We are getting there, but I feel like there's a lot of work to go.
Maybe not too soon, right?
No, I don't even think that we will solve AGI in the next decade.
Yeah, not too soon. You know, we still want to enjoy our status as the highest intelligence form on the earth.
Yeah, I think there's a whole like idea about like robotics and like like Isaac Asimov works about like how like human and robots would interact. But I feel like my personal take is that I think AI would like help us in terms of um like our tasks. Like they probably wouldn't replace us because I feel like they would mostly like, complement us. Like I would see AI like a tool, like a development technology that basically improves upon most most life. Okay.
All right. This question, this is interesting. I think related.
Yeah. Yeah, of course. As a machine learning engineer, do you develop state-of-the-art models? Would you publish your work in top conferences like CVPR? Yes, thank you for asking. I actually really like going to conferences. What I do is basically like, um, there are like there's a main conference and there's like a conference workshop. So conference workshops are more like a smaller scale. They're targeted towards like a more targeted category. And those are essentially like, I would say, they're easier to get into, and of course like there's a good way to kind of get started with conferences. So in the past I actually did publish a few papers. They were in several conferences, and basically like I got to go to ICML, CVPR, when I was doing my undergrad and graduate school. At Apple, I think also like we're trying to go to conferences this year, so like new rips, like ICML, CVPR, iClear, those are the main conferences we go to. As a machine learning engineer, I do also work with like state-of-the-art models. So for example, like when ResNets or transformers came out back a few years ago, people try to like actively try to incorporate transformers into their workflow and see if there would be like a huge, they'll give a performance boost. So yeah, I do actively work with this. I also feel like that's one of like the favorite parts of the job that I get to deal with. So how do I know if deep learning works the best compared to SVM or random forest? Deep learning models tend to be large. Are they worth it for smaller data sets, such as medical lesion segmentation? So I feel like, let me answer the first question first. So in most tasks, I would recommend trying like SVM or random forest first, like or decision trees, because I feel like deep learning is not like a one size fit all tool. So if let's say your data set is only like 1,000 samples, I do not recommend deep learning. Because I think they would very easily tend to overfit the data. So deep learning works probably in a scale of like, let's say, um, like tens of thousands or hundreds of data samples to let's say a few million. Let's say if you have like smaller data sets, what I would suggest doing is basically you would take like a pre-trained like ResNet and you can fine tune it on a smaller data set. I think that's what a lot of people work with right now in industry. So given like they take a pre-trained model and they fine tune it on a small model, because it's hard to train like a state-of-the-art model from scratch on small data set. Um, let's see. Does have okay. If we have limited data sets, what do you suggest to get more data sets? Um, Personal contributor with lower budget. Um, it depends on what kind of data sets you have. So I feel like a lot of a lot of people get data sets from Kaggle. Um, a lot of people, let's see. In deep learning, when people say the model is overfitting, essentially you're performing really well on training data, but not on test data. That's when you know that the model is overfitting. And one way to solve this is getting a lot of data sets. So what I recommend is basically in a small data regime, there are different topics. So you can either like take a state-of-the-art model and fine tune it. Fine-tuning model is I think one of the most popular strategies. There are also ways of like doing like K-fold validation. Data augmentation is also very important. So let's say for images, right? What you would do is basically you would flip the image like horizontally, because let's say a dog in the mirror is still a dog. So what you would do is basically you would do augmentation from like that, like doing image flipping. You would do like image cropping, because let's say if you have an image of the dog, you crop like a segment of it. I think they would also like improve performance. So I would highly recommend looking into data augmentation. Um, Yeah. What approach would you recommend to get top like this that cause a yield drop instead of using visualization? Plotting trend chart by parameters.
I think
Let me
it's like
try.
feature importance, right?
I think so. I think my interpretation of this question is, let's say, um, what causes. So let's say if you're trying to, let's say, nail down a metric like a loss function, or let's say a performance on a given test set. Um, I'm not exactly clear what the visualization part means, but let's say I'm guessing like by plotting trend chart by parameters. So let's say you plot out a trend over time, and you're seeing that the model is. Hmm, that's a tricky question, because first thing I would do is basically I would figure out whether the model is overfitting or underfitting. That's the first strategy. Like maybe the model is underfitting in the sense of like, um, actually, let me take it back. Let me take it back. Let me backtrack a little bit. So the first way to debug machine learning models that I highly recommend is training on a very small data set. So, and then you should also like evaluate it on the same data set. So for example, you train on like 5,000 examples. You evaluate it on like maybe like 1,000 out of those 5,000, the exact same ones, because essentially you want to make sure that you can memorize the data set first. So let's say if you're trying to take an exam, um, it's like taking an open book exam. It's a similar strategy. Let's say, you want to make sure that you can actually like know how to read, know where to find the information that you need. And then basically once you make sure that the model can fit the small data set, and then that's when you try to like, determine whether the model is underfitting or overfitting. And that's when you would try to use things like plot out the trend, like the train and the validation curves. So I would say plotting the trend chart, plotting like the training and validation curves is still like the recommended way to go. But like iterating in terms of like getting like the feature engineering and stuff, I would say it's also pretty important. So
Thank you, Dian. I think we actually finished most of the technical questions, and we do
okay,
have like a number of internship or career related questions that you
yeah,
may have want to answer. I think we
right.
can start from this one. Does having a certifications helps or not necessary?
Yeah, I feel like having a certification helps, but I feel like my main priority would mostly be like like basically like trying out projects. So let's say like Kaggle competitions, um,
Yeah.
like basically Kaggle competitions would be helpful, like forking GitHub repos and like running them, like tweaking them would be helpful, and like basically like coming up with your own project. So I feel like what people look for in most cases is like experience in terms of like trying out previous strategies.
Thank you for that, because I actually took one Kaggle topic as my assignment and students were complaining, but I hope with your advice, they are not complaining anymore. All right,
I
so
feel
we
like
can move on to the other two questions, which is really about interview. I think this is like, how do you
yeah,
get your job, what skills that you need, and how to
right.
nail coding interview.
Yeah, okay. I'll start with the nailing coding interview question. I think this one, like mostly I would just practice lead code. So basically like learning in terms of like how do you um like software engineering is a very fundamental skill. So I think in one of the past, I was also an interviewer. I've interviewed candidates before for machine learning engineer roles and also like software engineering roles. Like even if someone is really good at machine learning, like they publish a lot of papers, they have PhDs in top university, if they cannot solve like a recursion problem or like a dynamic programming problem, like we would not choose to move forward with the interview. So one way to build like intuition is basically like I would say try out lead code, work with like basically like work on the fundamentals of like algorithms, data structures, recursion, and like dynamic programming. Like so,
Yep.
what I did for my internship is that I think in my second year of college in the summer, I basically give myself a rule that like, oh, I want to solve like 2 problems a day on lead code. So I highly recommend it. Like a lot of them are free. So like lead code is like, I think I have the link later. I can share the link later as well.
Yeah, I think
Yeah,
that LeetCode is really a popular platform, right, among the software engineers. I even heard it from my friends who are working on Meta and Google,
mhm,
that they are using that even to evaluate the candidates. But there's
yeah,
also more platforms apart from LeetCode. I can't remember, but it's getting like more and more coding platforms. Uh,
exactly. Yeah,
yeah,
I
and
feel like yeah.
sorry. this is related to internship.
Right.
Oh,
Yeah, internship. First of all, like congratulations. Like I highly recommend like doing internships. You know, like it really helps you fill up the resume really quick. Um, like definitely it's a little bit frustrating at first because let's say if it's really challenging to build up your resume, like there is a cold start problem because there's a cycle that like jobs need experiences and experiences come from jobs and there's like a negative cycle. But what I recommend is basically like first of all in industry referrals really help. So maybe like you can ask someone to submit a referral for you, that basically gets helps you like get your resume being noticed by the recruiter. And what you should include what you should include in the resume involves like um, things you should focus on. So there is a lot of like good resume, like there's a lot of good resume profiles out there, and the one of the few best resumes I've seen like explicitly say that like, oh, I improve performance on this data set by like 10%. Like you can actually quantify them. Um, like they would actually like also mention things like, oh, like I try out this new algorithm, I develop new strategies. Let's say if I like like try like a Google GitHub repo, you can say that like, oh, I basically like build upon an open source platform to basically improve this. So yeah.
yeah, I think students are actually asking like, because they
Mhm.
wanted to apply for an internship, but yet they do not have any working experience. And sometimes maybe the employer prefer them to have internship experience before. But what I'm telling the student is, if you are still studying like a second or third year student, right, employer would be more lenient if you do not have prior internship experience. But if you
Yeah.
already graduated, then they will ask, why don't you do any internship? So for students who are
Mhm.
joining this course, right, we do have industrial guests, from Naeem and Science, who are actively looking at computer science students from Swinburne for internships. So do reach out, if you want to find an internship to the related professional in Sarawak who can offer you an internship. And we also publicize it on Canvas. So do check it out, right? Just some advertising here. So I think,
Yeah.
Dian, back to you. This is a good question. Would it be better to pursue graduate study in mathematics, CS, or AI if you want to become a machine learning engineer or scientist? And I think the
Yeah.
graduate study may refer to master or PhD, right? So you can share with your two cents.
I highly recommend like let's say if you want to pursue like machine learning engineer or scientist, like CS and AI would be the way to go. I know what a lot of people do is basically like they do their undergrad in like math and then do their graduate studies in CS. But I don't think like like it doesn't really matter. For me, I think what matters most is basically like math. Math is like a good fundamental to know. Like you can basically also pick up things like linear algebra, even though you did not major in math. So even if you're like a CS major, I feel like that's also like sufficient. But a lot of people that I'm aware of like work with CS. Um, I know that people. I don't know if there is a specific AI major, but usually what happens is I think in a lot of places AI is like a It's like a specialization in CS. So
Yeah.
there's like Berkeley, yeah. So basically, this is CS is a major, and then in CS you can choose to specialize. People do like systems, people do um, like AI, people do like let's say user design, front end, and then that's where like a lot of people focus on. Yeah.
And I think
Um,
we have some questions here.
yeah.
Yeah,
How to get remote internship? Yeah, I feel like remote internships right now are like much easier to get because of COVID and work from home. Like like I would say like keep applying. There's a lot of like places that like back then there was a whole list on GitHub that basically compiles like internships. I feel like if you just go to Google, you search like internships, GitHub, there should be like a list of like all the companies that you can apply to. I think a lot of them are like specifically targeted like in the US, like there's like Spotify, Dropbox, a lot of companies, Reddit, Discord, but um, but yeah, like people just want to see that like you're actually enthusiastic about the work, and yeah, do a boot camp or short course certificates boost your resume. Like if you have it, definitely include it. But I feel like most you shouldn't be basing like the en- the entire resume centered around a boot camp or certificate. Like what's the most useful one is basically like experience and projects. So experiences come in the form of past internships. Projects can be like Kaggle competitions, forking out like current GitHub repos. Um, yeah, I think those would be important. Like, but if you do have certificates and bootcamp, definitely highlight it.
Yeah, we take
How hard?
one last question. Okay,
Yeah,
this is the last question for you.
yeah. How hard is it to get into FANG companies? Um, right now, I mean, like right now, I think it's much harder because like the US job market is very tight in terms of like, in terms of um, things are not looking good for Facebook. There is, yeah, people are like, there's a lot of layoffs from Netflix. So I would say in the current situation, like in the next 6 months, it's a bit tricky, but I definitely like it doesn't matter in the long term because there is always a demand for machine learning engineers and computer science. Like I think that's one of like the first few sentences that my professors highlighted to me. Like there is never a shortage of like computer science and like AI ML roles because there's a lot of companies who are trying to get into that and like help scale up things really quickly. So even though it's hard to get into like a FANG company in the next 6 months, don't be discouraged because it's just a job market situation. But definitely like there will be a lot of people who want to recruit. What I'm aware of is basically people usually do internships at FANG companies and then convert to full time, or let's say they would pursue it like other non-FANG companies too. Like I don't think that being a FANG company itself, yeah, I would say that there is some prestige in being a FANG company, but basically what most people do is they would work at somewhere else. Like other people work at Visa, people work at like Reddit, people even work at startups. Oh yeah, I think yeah, something to mention. I think it's also really good to also work at startups because you also get like a good exposure of like what things are, and like it's also like I think easier to get into than a FANG company. And if you work at a startup before, like you would like there would be like a boost in your resume. So I feel like that's also like a huge recommendation. Any suggestions where we can start if we wish to land a position in any other companies? Yeah, I would say start from internships. People also start from startups as well. I know people who actually like join startups and they mention it on their resume, talk about like what they did in the startup, and that's also like a good thing. So,
All
oh, the
right.
last one. Do we get this
You want to
Apple
take the
product?
last question?
That's funny. I feel like okay, as an Apple employee, I think you get 15% off Apple
All
products for
right.
friends and family. So
It's quite expensive to get Apple products here, right? In Malaysia. So with your discount, that's good. All right.
yeah, yeah.
Let's
So
move on to the next question. I think we are running out of time already. Time flies. 11:57. Over there, I think it's at 57 for you, right, Dian? So I would
yeah.
just like to, ask the participants to summarize these sessions in one word. And many thanks for your dedicated sharing, and very generous advice given to our students. I think they really learn a lot from you, and it's very motivating and inspiring for them to find an internship in the coming break. In the next 3 months, they will have a short break. So hopefully they will find some internships to do locally or even internationally.
Mhm.
So how do you feel, Dian, to be connected to
Yeah.
back to
Thank
the
you.
Sarawakians?
Yeah, thank you. Yeah, thank you for the invite. I mean, I enjoyed it. I enjoyed preparing the presentation. And I think by teaching, you also learn about like a lot of things
Yep.
that, that that you don't see it while you're a student. So
I can't
yeah.
agree
But yeah,
more.
I definitely like recommend like, like my takeaways that machine learning, like CS jobs are definitely like in demand. So even if you don't get in like I wouldn't let your entire success be defined by you trying to get into a company. Because overall, if you find a passion that you're inspired by, like let's say if you're trying to basically like trying to solve a problem and build a model to achieve that, I feel like that's like the ultimate. That's the best feeling. I wouldn't like define success by being. I wouldn't define success by a separate entity. Like let's say getting into like Microsoft or something.
Mhm.
Yeah. But of course, like, just because you don't get in like the next 6 months, like, oh, like 1 year, like just keep trying. I feel like for me, like I sent out what 200 resumes everywhere else. I was initially rejected by like Facebook, never got anything back from Facebook. Google as well. A lot of places I never hear back. Twitter, I never hear back. Um, and I basically I've being on the interview side, like we get a lot of resumes, and then basically like they have to like filter them and like get through them. So just because like it doesn't, yeah, you don't get selected, like I would say keep trying, keep hiring.
Yeah, I think that's really important, right? If you never try, you don't even get the possibility to get accepted. So even though you have tried many times but no news, just keep trying. It's from my personal experience also. I just keep trying. And I just graduated. It's so difficult to get a job. back then as a biomedical engineer in Singapore. But who knows, you know, I actually actively participate in some events and even competitions, and that competitions actually land me a job. So
Oh,
you
really?
never know what will bring you.
Yeah.
Yeah.
Well, I never know. You never know what lies will bring. So
Yeah. So last question. Would you like to attend a similar speaker sessions again for the audience, just for Swinburne to collect your feedback? If yes, right, maybe we will share with you the events in the next round. So I think that's all for this one. I would like to invite Dian Ang, please stay back. And the rest of the audience, could you please, you know, turn on your video and we can have a group photo? Right. And Dian Ang, is it fine if I share the recording with the student who missed it, or would you prefer it to be
oh, yeah,
PNC? It's fine.
that's fine. That's
All
fine
right,
with me. So
then I will share it with
there
the
there is
students.
no
Okay.
there is no non-disclosure agreement, I
Yeah,
suppose.
yes, no PNC, right? Try not to mention any secret projects, otherwise you'll be in trouble. So just keep it general. So
Right now, what I'm talking, a lot of this is basically like what the field of ML is. You know, like it's mostly like I feel like a lot of these like like conferences are meant to be like open source, so people like talk about like research progress in conferences, what kind of problems like they're facing. So I feel like having this kind of communication is also important. But other than that, like non-disclosure agreements aside, I don't think like everything here is like
yeah,
public.
the
So
NDA, right? Okay.
mhm.
Then I think everyone, can you just you know, share your on your video and we can take a group photo. Thank you. I just wait for the rest to